Hello, everyone. Welcome to our intermediate algebra course. For this class, we're going to use the Ellen Martin Gay intermediate algebra book, the 8th editions. I would strongly advise you to go through the syllabus for more information about the description of this class, the objectives of this class, at the end, what we expect you to learn from this class. Evaluation criteria, I covered that in the syllabus, and potential timetable, all the chapters per week, what would cover, when homework would be posted and when homework is due, quizzes, tests, they are all available in the syllabus. I strongly advise you to review the entire syllabus. I give information on how to find help on campus. If you need any accommodations, who you should contact, I give all these information in the syllabus. So I strongly advise you to review the syllabus and get back to me as soon as possible. So we're going to start with chapter 1. Chapter 1 covered real numbers and algebraic expressions, in section 1.1, we give you some tips for success in mathematics. So we're going to go do an overview very quick about these tips before we start with section 1.2, which is algebraic expressions and set numbers. So study skills tips for success in mathematics. Before you really go through everything, remember me as your instructor for this class, for this course, I am your primary source of information for this class. So if you need anything, or you can reach also out to your college campus, your advisor also, but for this class particularly, I am your primary source of information. All right. So reach out anytime you have questions. I'll be happy to answer. Just allow me about 24 hours, maximum to reply to your emails and so forth. All right. So let's get started. We said that because you decide, of course, to take this class. So remember that a positive attitude will make all the difference in the world. You believe that you can succeed is just as important as your commitment to this class, all right? So you need to make sure you are ready for this class by having the time and positive attitude that it takes to succeed. That's very important, all right? So and another one is make sure you have scheduled your math courses at a time that will give you the best chance for success, all right? So you decide to take this class online, then you need to make time for it. Every one course credit, you need to spend 2 to 3 hours outside of this class to do your homework, quizzes, to read, to do research, so it's very important to put some time for this class. You need to be prepared, have all the materials. You need to have the book, you need to have the online access code so you can register for this class on Pearson My Math Lab, because that's where we're gonna have all the assignments. We're gonna have homework, quizzes, tests. Sometimes we might schedule tests on Blackboard, but I'll have all the time in the world to give you more information, to share with you more information about tests. But for now, we really need to focus on the general tips for success. All right. You need to get a contact person, of course, beside me as your primary or principal instructor. Make sure you know someone, at least in the general discussions on Blackboard, reach out to other students, get in touch with at least one of the students, or just in case you want to know what was discussed. If you have questions that I am not available at the moment to reply to your email right away. Of course, you can reach out to another student because you don't need to attend class when it's online, and that you can log in at any time, I mean, at your own time to uh, play, click and play the videos, and then you go on Pearson and complete your assignments. You can do that, but make sure you do your homework, you check your work, you learn from your mistakes. All right, always double check your work, especially when you do them online. Get help if you need it. Ask for help when you don't understand something. Know your when your instructor's office as me, hours are, and where the tutoring service are available. But of course, as I said, you have the tutoring service available on campus. Reach out to your learning center, and you would know when and how to schedule a sessions with a tutor. Organize class materials. You need to read your textbooks, lecture videos. Of course, you need to watch them. That will be available on Blackboard. Ask questions, speak up when you have a questions, and, handing assignments on time. That means prepare, get ready and try to complete all your assignments and quizzes on time. Help me solve this, right? Select this resource to get guided step by step the exercises you are working on. This tips is available on my math lab, so you can view another examples, because the one you're trying to solve is a little bit complicated and you don't quite understand, and probably maybe I didn't cover an example during the lecture. Remember, the book is a giant book. We would never be able to do all those 500 exercises per chapter. So I will just go over a few examples, few exercises. Then I'll let you enjoy the time to read the book and also read go over the examples on Pearson. Textbook, as I said, you really need to use the one you purchase using the ESBN number, ISBN number that provided in the syllabus for this book. All right. Ebooks and videos are available. Video organizers. The video organizer is designed to help you take notes and work practice exercises while watching everything. Remember, you can do that also on a Pearson My Math Lab. Get help as soon as possible. That's something we already talked about. Please take time, so you can pause the video at any times to read the details I provided. Prepare for and take an exams, with steps of preparing a test. Of course, everyone knows that you need to go through the lectures, review previous homework assignments, review notes from class and section levels quizzes you have taken, practice working out exercises by completing the chapter review found at the end of each book. Since homework exercises are online, you may easily work new homework exercises. Take a sample test in conditions similar to your test conditions. Remember, tests would be timed. All right. So, for example, we'll have 90 minutes, 100 minutes, 110 minutes, 120 minutes to complete big test, but 60 minutes to complete short test. Get a good night's sleep before the exam. Of course, I always advise all my students to do that. Set aside plenty of time to arrive, where you will be taking the exam, but at this time, because you're going to do it online, it shouldn't be a big problem for you. So you need to do it at the time scheduled for you to take the test, and of course try to get ready on that day, not on that frame time, because I would give you a frame time to do that. Read the directions on the test carefully, read each problem, carefully as you take the test, make sure that you answer the question asked. Pace yourself by first completing the problems you are most confident with, then work toward the problems you are least confident with. Watch your time so you do not spend too much time on one particular problem. Do not turn your test in early, because I always give you enough time to complete the test and also read everything. All right. So we said you need to double check, etc. Make a list of all your weekly commitments for the term, so that saves for making a schedule, right? You need to manage your time. That's very important, to manage your time, right? Estimate the time needed and how often it will be performed for each item. Remember, for every 1 credit hour, you need to spend between 2 to 3 hours outside of this class to complete assignments, to do your research. You should read this the different sections of the chapters and complete some extra exercises at the end of the chapters. Estimate the time needed and how often it will be performed. Block out a typical week on a scheduled grid. Starts with items with fixed time slots. Fill in items with flexible time slot. Remember to leave time for eating, sleeping, and relaxing. Make change to your workload, class load, other areas to feature in. So those tips I gave you for my success in mathematics, it's not really for this class particularly. You can apply it to any other courses you're taking, and even in your daily life, outside of the classroom, you can also apply those tips to succeed. I think we go over all those tips for success in mathematics. How about we start now with the real thing, which is the algebraic expressions and sets of numbers. So that's what we're gonna set. I would assume by now all of you have an idea how maths works. So you know there are 4 basic operations in mathematics. So we have additions, subtractions, multiplications, and divisions. Of course, we can add real numbers. We can add, when they say real numbers, those are numbers you really can verify, like 1, 2, 3, 4, 5, 6. You can, or even though it could be decimal, 2.5, it can be negative, -6, -6.3, it can be fractions, 1/3, 1/2, especially for those of you doing cooking all the time. You need to remember use a lot of quote, so a lot of decimal and also fractions. So we're gonna do all of this. But first of all, we need to go over algebraic expressions and sets of numbers, because we're not going to deal all the time with numbers that you can verify, like what is how old are you? I'm 18, I'm 20, I'm 30, I'm 35, I'm 40, I'm 46, etc. So those real numbers. But sometimes we can deal with expressions. Expressions is a combination of numbers and letters that we call variables. What we're gonna have a chance to see that, because the objective is to identify and evaluating algebraic expressions, identifying natural numbers, whole numbers, integers, rational numbers, and irrational numbers. We're going to find the absolute value of a real number, find the opposite of a number, right? Phrases as algebraic expressions. That's very important. Now, we talk about variable. Variable is a letter used to represent any number that we don't know. Anytime we talk about variables, we need to see that something we don't know yet. Let's say your weekly income. Your weekly income can be a variable, because once you know your hourly wage, That's something you know. Let's suppose you get paid $20 per hour. So you know the $20 you're gonna get if you work 1 hour. All right. But what would be your weekly income? What would be your income at the end of the week? It would be 12 multiplied by the number of hours you work. But how would you know the number of hours you work if you don't work it? So that's why I mean, 20, let's say as I said, it can be $20, right? So if you get paid $20 and that's what you get paid per hour. But if your weekly income is 20x, if we let x be the number of hours you work. Right? So that's what we're gonna do. So a variable is a letter used to represent any number. A constant is either a fixed number or a letter that represents a fixed number. So as I said, we're gonna see variable can be usually in mathematics we call variable x, we call it y, we call it z, we call it w. Those are example. Constant, that means we can have 0, we can have 1, we can have 20, I don't know, 155, etc. We call this algebraic, I mean, a constant. A constant is just a number, you know, it's either a fixed number or a letter that represents a fixed number, but usually we prefer to go with a fixed number. An algebraic expression is formed by numbers and variables connected by the, you know, operation of addition, subtraction, multiplication, and division. Or probably we can raise it to a certain power or take roots of it. But algebraic expressions, you know, is an expression that has letters and numbers. Of course, we're going to have some operation sign, addition, subtraction, multiplication, and divisions. For example, we can have algebraic expressions as 5x minus 8. All right, we can have also 6a squared minus 6a plus 40. We can have some other ones like t over 2. Probably we can have something like x power 3 minus x squared plus 12 over 5x, you know. Those are examples of you know, of algebraic expressions. Algebraic expressions can be even bigger as long as you have a combination of addition, subtraction, multiplication of variables and constants. We call it algebraic expressions. So what we do with algebraic expressions, we can evaluate an algebraic expression. So, you know, you substitute the numerical value for each algebraic, you know, expression. So you can evaluate them for each value. For example, if we said evaluate two x minus 5 for x equals 6. Okay, all we need to do, everywhere in that expressions we see x, we substitute it for 6. So we're gonna have 2. Remember we said 2x. Now x is no longer x. We know what x means. X is 6. All right, we substitute minus 5. So 2 times 6 is 12. 12 minus 5 is 7. So you see, we can evaluate expressions. But I give you something very simple. That's one of the examples. We said that the area of a rectangle is, you know, the length and width, with length L and width W is length times width. So if you have a rectangle, remember that the area for a rectangle. I put this is the area. So area is length times width. If they were asking you for the perimeter, we're going to add all the sides together. Now, if you know the area is length times width, all right, we can replace, because what they ask you to do, find the area of a rectangle where you see L equal 5 and W equal 3.5. 3.2. So all you need to do is substitute. We need to replace L with 5 and W with 3.2 in the algebraic expressions, L times W. So you end up having A equal 5 times 3.2, and what you said, when you multiply these two, it gives you 16. What was that again? So we said the area of length 5 meters, so that's going to be square meter. Okay. And let's say it could be the same for this one. All right. For B, they said, you see, we have that expressions B minus 5A. Now we know A is 4 and B is 35. So having something like that, if we need to evaluate it, we need to replace A with 4 and B with 35. So what we do, AB 35, 5 times A is 4. So we do 35. We're gonna cover order of operations, of course, and you would have more time to understand multiplication come first before the subtraction. I cannot do 35 minus 5. I need to do 5 times 4 first. So 5 times 4 is 20. Then we do 35 minus 20. That gives you 15. Okay. All right. It's a brief introductions of algebraic expressions. I'm hoping you get it. But now it's very important to learn how to identify real numbers. So if we want to talk about real numbers, first of all, we need to know what the number line is. All right, number line is very important in the process of covering all those math questions later. A number line is a line on which each point is associated with a number. So when we do the number line, we know right in the middle you have 0. If you go to the right of 0, you have the positive numbers. It's very important later when we have to graph to understand this. And when we put this arrow, we mean we can continue indefinitely, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and you get to 1 million, 2 millions, and you can continue count to 1 billion, of course. And on the left of 0 is negative numbers. So that's what we said. You can go left or right of 0, right? On the left, negative numbers. On the right, positive numbers. Look here, I put only whole numbers, like no decimal. But know that if I have to put 2.5, I know 2.5 would be between 2 and 3. So 2.5 would be somewhere here. It's not because I put whole numbers that I cannot put fractions. If I have to put negative 3/2, negative 3/2 is 1.5, or negative 1.5. I can say negative 3/2 here. There should be no problem with it. All right. So that's the number line. What we're gonna talk more about in this class is the set of real numbers. When we have real numbers, has the set of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. I'm gonna just include another slide right here to show you something. Let's try it. I'm hoping I can do that. Give me a second. I put a blank one. Okay, let's put a blank one right there. Okay, what we mean by that, all numbers, if you have numbers, numbers can be, so far, what we're gonna use, so far at this level, we're gonna use only real numbers. And later we would use some complex numbers. Okay, for now, let's focus on only real numbers because we're going to talk about complex numbers later. For real numbers, you can have, in real numbers, you do have natural numbers. Natural numbers are all positive numbers. All positive numbers from 1, 1, 2, 3, 4, 5, etc. Right? That's natural numbers. Okay, natural numbers are all positive. Positive numbers, all positive. Natural numbers would never be negative. Natural numbers would never be decimal. Natural numbers would never be fractions. Natural numbers are whole numbers. How many siblings do you have? You have 3 siblings. How many members in your household? You have 5. How many TV sets you have at home? You have 3, you have 4. You see, those are all whole numbers, no negative as well. You have whole numbers, whole, we like to say whole numbers has a whole on it. All right, so whole numbers that has a whole, of course, they are all positive numbers and 0. So you start from 0, 1, 2, 3, 4, 5, 6, and you can continue indefinitely. No negative, no fractions, no decimal, right? The whole numbers. The difference between natural numbers and whole numbers is because whole numbers has 0, started from 0, and natural numbers starting from 1. All right. So all natural numbers are whole numbers, but not all whole numbers are natural numbers. The third set we have from real numbers are integers. Again, so far no decimal, and for integers as well, there is no decimal. Integers are all positive, negative, and 0. So like you can go from, I don't know, -3, -2, -1. You can have 0, you can have 1, 2, 3, 4, 5, etc. So you see, I put some ellipsis point. The 3 dots means ellipsis points. I put them just to say you can count to the negative side indefinitely or to the positive side indefinitely. Integers also has no decimal, no fractions. And other set of real numbers, we call them rational numbers. So far, integers can be natural whole numbers, but whole numbers cannot be, or not all integers can be whole numbers, not all integers can be natural numbers. All right, rational numbers, we can say it's almost everything. Rational numbers are everything. Like you can have positive numbers, you can have negative numbers, you can have 0, you can have positive numbers like 4, you can have fraction, you can have negative fractions, you can have negative decimal, you can have positive decimal, and I don't know, you can have any types of numbers. So every number you can think of, like decimal, fractions, positive numbers, negative numbers, they are all rational numbers, right? But I'm not talking about complex. Remember, complex, we're gonna leave the imaginary numbers for some time, for another time. But for now, let's focus on real numbers only. The last set of real numbers, we call them irrational. Don't try to fix something that is not broken. So that's right. That's irrational, I would say. Irrational numbers, like all the other numbers you have. If you sometimes if you take the square root of 4, it's gonna give you 2. 2 times 2 is 4. Square root of 9 is 3. 3 times 3 is 9. But square root of 2, for example, is 1.41 and a lot of digits after that. But if you try to do 1.41 times 1.41, you would never get back your 2. So we can consider those numbers as are numbers that are not whole numbers, that are not natural numbers, that are not integers, that are not rational numbers. So we call them irrational. For example, if you see the symbol pi, everyone knows what pi is, right? What's the numeric value for pi is 3.14, right? That's and it has like billions of digits, all right? Billion of digits. And we have square roots of any number that doesn't give you a whole number when you take that is not a perfect square, right? So square root of 8, square roots of 14, those are examples, and some other symbols you might see, like E. Value for E, numeric value for E is 2.718. You can consider it here as well. So at some point, you can say the real numbers are rational and irrational. Rational numbers, remember, natural numbers are rational numbers, whole numbers are rational numbers, integers are rational numbers, but not all rational numbers can be these sets mentioned previously. And irrationals has nothing to do with rationals. If you are in the irrational, you stay in the irrationals. All right, so I give you tips on how to complete this. You understand now what are the natural numbers are all positive numbers. Whole numbers, all positive numbers include 0. Integers are all positive, negative, and 0. Rational numbers are all numbers in general, positive, negative, decimal, fractions, rational. Irrationals are all numbers that are not rational. Any numbers that are not rational are irrational. Okay, so in describing some of the previous sets, we use a 3-dot symbol. We call it an ellipsis, you see? So because I didn't want to put all the natural numbers. Remember natural numbers? We said, remember natural numbers? I said it's 1, 2, 3, 4. Now you understand the pattern. I just put 3 dots, all right? It means to continue in the same pattern. The objects of a set are called its member or element. So 2 is an element of the set natural numbers. When we list or attempt to list with an ellipsis the elements of a set, the set is written in Worcester list, like when we list them like that. So we call it listing, but because we have 2 ways to write a set. We can either do a Worcester form or with listing methods, or we can use a set builder notation method. So a set builder notation method, a set can also be written in set builder notation method. This notation describes the members of a set, but does not list them. Like if you see I write something X such that the set of all X such that the set of all X, that's how you read this X, that slash, we call it such that X is an element is an even natural number less than 10. So now this is the set builder notation. If I want to rewrite this one, what are the set of natural numbers, even natural numbers? Even. Remember, we have odd numbers, we have even numbers. Even natural numbers less than 10 would be 2, 4, 6, 8. I cannot put 10 because 10 is not included. It's not, and you said less, and they don't say less than or equal to 10. Now, with that, how about if we write each set in a roster list? Now, they give us the set builder notation for AX such that the set of all X such that X is a whole number between 1 and 8. Make a list of whole numbers between 1 and 8. They don't say even whole numbers. They don't say odd whole numbers. They only say between a whole number between 1 and 8. Okay? It is a whole number between 1 and 8. Now, they should say two ways, because this question is a little bit confusing. They should say if it's either inclusive, that means 1 and 8 is included, or excluded. But because they don't say anything, we said between 1 and 8, we're gonna take only 2, 3, 4, 5, 6, and 7. We could take 1 and 8 if they said inclusive. B, X such that X is a natural number greater than 100. You see, for A, I don't put any three dots. But for B, they said X is a natural number greater than 100. Natural number greater than 100. I would assume we're going to start with 101, 102, 103, 104, 105, but I don't know where to stop. How would I do that? Because they don't tell us between what and what. They said just greater than 100. Yes, because we cannot list all of them up to trillions, 3 trillions, or the American vet. What we're gonna do, you will use the 3 dots that we call ellipsis points. That means you can continue to follow the same pattern because we count by 1, adding 1 each time. So the next one will be 106, 107, 108, 109, 110, etc. We can do that way. Very important. That's very important for this. Okay, let's go over some of the examples very quick, because we have so many examples to go to. Determine whether each set of a statement is true or false. We remember we said all the members you see in a set, we call them elements. So do you feel like 0 is an element of the set that says the set of all X, so that X is a natural number? Is 0 a natural number? That's false. This one here, false, because 0 is not in natural numbers. Natural numbers start with 1. Is 9 not a member of that set? Remember, we said not a member, because if you use this is an element of, and if you put it like this, is not an element of. All right, so 9 is not an element of the set. That's true. There is no 9 here. So we're gonna say this one is true. It's true. 9 is not an element of the given set. So well, we're gonna do that. Now, I think you'll see at some point what we had to say about everything. We're gonna go, because we said here you have all the sets of real numbers, natural numbers, whole numbers, integers, rational numbers, and irrational numbers. We're gonna continue, because here I just give you the definitions. Set the numbers, real numbers, the set of all rational and irrational numbers combined, X such that X correspond to a point on the number line. Rational number, the set of all natural numbers that can be expressed as a quotient of integers, with denominator not equal to 0. Of course, when we said I give you examples of numbers, not variables, but if you have any x divided by y, if you have two variables, you need to make sure the denominator is not equal to 0, because remember, 0 over 5 is equal to 0, but 5 over 0 is what? Undefined. Undefined. Okay? Irrational numbers, the set of all numbers that cannot be expressed as a quotient of integers. X, or the set of all x, such that x is not a rational number. So if it's not irrational numbers, then it's irrational numbers. But let's see that. Determine whether each statement is true. Do you think 0 is a real number? Yes, 0 is a real number. Real number is everything. It's everything. Every integer is a rational number. Is that true? Yes, every integer is a rational number, but not all rational numbers are integers. So this one also here is true, because you find negative, positive, and 0 in the rational and also in the real numbers. Okay. Do you think square roots of 3 is a rational number? No. Square root of 3 is not a rational number, because the square roots of 3 give you decimal. So 1.73, I believe. So that's decimal. So it's false, But square roots of 16, because square root of 16 is 4, is rational number. Right? Is rational number. Square roots of 36 is rational number. Square roots of 81 is rational number, because taking those square roots is give you a whole number. So those are perfect squares. All the perfect squares are rational numbers. You have an idea on how rational numbers works, real numbers works, irrational numbers work. How about with the absolute value of a real number? The absolute value of a real number, A, denoted by the you see two straight line. Remember, when you take this the absolute value of a number, we put it that way. Like, for example, if you do absolute value of 5 is equal to 5, and absolute value of -5 equal what? Yes, still 5, because we don't look at the name, we like to look at the distance. It's the distance between A and 0 on the number. Like, you look at the distance. You don't see that you're running from 0 to -4. That gives you -4. You see that you run 4, right? Like 4 miles. It's like you drive 10 miles to go to work. You drive another 10 miles to go back from work, back from work. Then it's not -10 miles when you drive back from work. If you drive 10 miles to go to work, when you go back, it's not -10, so it's still 10, so that's the distance. We can do so many examples using absolute value, but let's say absolute value of 7 is what? Yes, absolute value of any negative number is always positive, so you can just get rid of the negative, but absolute value of 0 is 0. But what is absolute value of negative? Let me do it with a different color. -3. The absolute value of this is still 3. Negative absolute value of -8 is what? Yes, it's -8, because the first negative sign is outside of the absolute value. So either we do a negative absolute value of 10, is going to be -10. Remember that, because the first negative, the negative is outside of the absolute value symbol, right? The opposite of a number, how'd you do that? We said two numbers that are the same distance from zero but lie on an opposite side of zero are called opposites or additive numbers, right? Let's say the opposite of 3 is -3. The opposite of -7 is 7. That's an example. I think I'm hoping you get it very quick because that's about the distance. So to find the opposite of a number A is the number with negative A. Double negative property. So if you do, let's say, for example, if I do minus -6, two negative in multiplication become positive. So we're going to have this one become positive. So that would be +6, right? Double negative property give you a positive number. Like, what is the opposite number of 35? Opposite is 35. I mean, sorry, -35 give you 35. Opposite give you what for 12? Yes, -12. Thank you. Opposite give you what for -311? Yes, 3/11. I just removed the symbol. And you see the opposite for 1.9 is what? Yes, -1.9. Okay. Very few examples to go about how to write algebraic expressions. Write phrases as algebraic expressions. You can use some words to express mathematical models, like 3 + 5 is words that you can express in numerical values, but you can use plus, sum, added to, more than, increase by. A difference of minus, that's subtraction, multiplication, and divisions. Many words, when you hear it, you know what they ask you to do. For example, in example 7, they ask you to write as an algebraic expression if you let x represent the number you don't know. Usually, if you don't know a number, 5 decreased by a number. Let's call this number x because we don't know it. But they said 5 decrease. You have 5, you remove a number from it. That number can be 1, 2, 3, 4, 25, 26, negative something. But because we don't know what is that number, we replace it by x. But decrease means subtraction, right? So x, because decrease subtraction, all right? The quotient of a number, if we said of a number, then we're gonna call it x, and 12. The quotient means what? Division, right? Quotient means division. So the quotient of a number, what's that number? We call it x, quotient, and 12. You can write it like this, or we can say x divided by 12. Okay. It's really express it. Okay. You can translate also into algebraic expressions. The sum of 4 and twice y. Sum means addition. 4 and twice. Twice means 2 times, right? Y, twice y. So we have 4 plus 2y. So that's what we're gonna have for this one. X less than the product of y and z. Now, product mean multiplications, right? X, because they tell you, we're gonna say X less than the product, not decrease by. So less than the product, we're gonna have product XY. So that means we're gonna have a YZ as a product. So we have YZ as a product, okay? And minus X, okay? Now, for this one right there, we're gonna have 3 times. 3 times mean there is a 3 times the difference. Oh, because this one I'm gonna put parentheses of a number and 10. Difference of a number that we don't know is X and 10. Remember, we said difference. 3 times mean multiplication. 3 times the difference between two numbers. So difference between two numbers, we must put, a parenthesis. Now for the last one, C, 1/4 subtracted from 3 times a number. So you have 3 times a number that I don't know, I call it X. I need to subtract 1/4 from it. We translate phrases into algebraic expressions. I think that's it. That's all for these sections. We're gonna come back in a different video for the next sections, because next sections would be all about operations on real numbers and operations and order of operations. All right. So hopefully you enjoyed this first video. Let me know if you have any questions.